It's called Ethernet channel. It's called Ethernet channel. Basically, it's about integration of several links together from a switch. Okay, you integrate links together from a switch just to ensure that you improve on stability of the network, and you do what we call load balancing. Okay, so I've uploaded the lab of that. For today, I've uploaded labs for 3 topics or 3 modules, and you can have a look at them. Use your packet tracer maybe to do the labs. The labs are there with all the syntax, so yours is just to read it through and pick the relevant steps and configure those devices. So the lab is a follow-through process, so you don't need to think about it, or you don't need to really come up with a new codes unless now you want to modify for your own benefit. So I'm saying there's a module on what we call Ethernet channel. Okay, so it's basically combining several interfaces of a switch together. Okay, so that you improve on bandwidth and you improve on what we call load balancing. Okay, so it's like when you have pipes, 3 pipes that are supposed to be draining out water, okay, to different locations. So you decide that these 3 pipes now, I'm combining them together to supply or to drain water from a single location or a single point. Okay, so you put them together to enhance that kind of the outflow or inflow, whichever direction that is moving. Okay, so that technology, that technique of putting up several interfaces of a switch together is what we call an Ethernet channel. Okay, is what we call an Ethernet channel, or rather, you'll find it written as the Ether channel, ET. Okay, you can just share that out, then you let me know. Okay. So this is the module I'm talking about. Okay, that's the module I'm talking about. Okay. So you'll have a look at it. Just have a look at the lab and see exactly what it is. It's just basically a technology where you put up together several links from a switch. Okay, like what is provided there. Okay, so we call that particular link or that particular channel an Ether channel or an Ethernet channel. When you put up these 2 together, okay, you put us those 2 links together. So reasons why we do the Ether channel, reasons why we do the Ether channel is to ensure that one, we are in a position to do load balancing. Okay, we're in a position to improve network utilization or bandwidth utilization. So once we improve the network utilization or bandwidth, then definitely we expect our network to do better in terms of service delivery or efficiency in communication. Okay, so Ethernet channels also provide what we call redundancy. Okay, so the logical combination of those several links will provide links that are idle and can be activated to function when the primary link fails. Okay, it's almost a similar concept to what we were looking at on STP. Okay, where now some ports are blocked. Okay, and some ports are unblocked. when the primary channel fails. So it's the same thing here. So when you do what we call Ether channel or Ethernet channel, then you avail into your network redundant links that can be used in case the primary one fails. But you don't need to confuse that with the ability of Ethernet channels to ensure faster communication in a network, because the purpose of putting up several interfaces together logically, okay, is to ensure that if we are transmitting 10 gigabits or 10 Mbps or 10 MB, okay, if you're transmitting 10 MB, this 10 MB can be divided into 3 if we have 3 interfaces combined together, okay? Then each interface is going to transmit probably 3.3 MB, okay? So if our net is doing 3 MB per second, 3 Mbps, then this 10 MB, instead of being transmitted in 3 seconds, it will be transmitted in 1 second, okay? Because we have 3 interfaces now doing this transmission with the same original speed, which was 3 Mbps, okay? So we divide that into 3 different packets of frames, then it can be transmitted now in 1 second instead of 3 seconds. So that's the original purpose of the Ethernet channel configuration. Okay, we are working on the throughput of the network. We are improving that concept of throughput of the individual networks. But at the same time, because of load balancing, okay, some interfaces combined together logically might not be used, okay? We might not use them. So those are the ones we are calling the redundant ones, okay? The redundant links that can be activated for use in the in case the primary link fails. So now this concept of Ether channel is a logical process, okay? Is a logical process. You remember our route on the route on a stick when we were doing inter-VLAN communication or inter-VLAN routing. We were creating logical interfaces out of one physical interface, okay? So out of one physical interface, we could create 3 or 4 logical interfaces, what we also call sub-interfaces. Now, that is the same thing. That is exactly the opposite thing we are doing here. So instead of creating additional sub-interfaces the way we did, here we are not doing that. We are picking now the physical interfaces and merging them together logically, okay? Merging them together logically. So if that particular protocol is configured, then the switch now knows. It's upon the switch based on the memory or the intelligence of a switch that I use today to be able to balance. Do I need to do transmission through all these 3 interfaces at the same time? Do I need to use 2 and let one be a redundant copy? Okay, so it's upon the switch to do that particular comparison through that process. In other service providers, maybe like Huawei, they'll call it link aggregation. Okay, what we are calling the Ethernet channel here is the overall name is link aggregation. You aggregate links together logically to form one single logical interface. Okay, so now this chapter here, there's not much to be done this particular chapter apart from knowing how to combine these interfaces. And most importantly, that you need also to remember in link aggregation is that the interfaces you're putting together, must have similar properties or must have certain characteristics that are shareable. Okay, similar characteristics that are shareable, meaning issues such as communication speed, Okay, are we doing duplex, full duplex, or half duplex? Okay, it has to be the same. Okay, so implementation restriction to forming link aggregation or forming Ethernet channels include that interfaces must be doing the same communication speed, half duplex or full duplex. They must be doing either gigabit Ethernet transmission or fast Ethernet. You don't mix this kind of communicating interfaces. Another restriction is that depending on the type of switch you're using, Cisco, for instance, 2960 version of a switch supports up to 6 Ether channels. Okay, so that's how much you can be able to do in that particular process. Also, in case your network has VLANs, then interfaces that are being combined together must belong to the same VLAN. Okay, they has to belong to the same VLAN. And of course, you want combined interfaces that are operating like trunks with interfaces that are operating like access. It's not going to work for you if you try and do that. Okay. So those are basically some of the restrictions that, or some of the things you need to remember when you're doing link aggregation. So what you just need to remember is very simple. Link aggregation. One, you put several interfaces together purposely to enhance the throughput of the network. Okay. When putting those interfaces together, you need to remember that all the communication properties up to this particular level, we should be at the same level when we talk about the communication properties in a network, specifically on a switch interface. All the communication properties has to be the same. Transmission speed, transmission type, full, half, VLANs corresponding, functionality of the interface within that network. Is it a trunk? Is it an access? And so on and so forth. Okay. Then, to support this particular process or to support this particular initiative, there are what we call protocols that will be used to enhance or will be used to push the process of link aggregation. You can do it manually, but manually the problem is you'll be involved in a lot of tasks. Okay, among them you'll have to check the communication properties or whatever we call the implementation restriction. You'll have to go through them one by one and check if the interfaces conform to those particular requirements. If I want to put interface fast Ethernet 01 and fast Ethernet 06, I'll have to go and check if these particular interfaces conforms to the restriction that we are talking about. That's how the manual one will be done. So that is a bit difficult. So what do we do if you want to do some of these things a bit faster? There's what we call the implementation protocols. Okay. Implementation protocols. We also call them auto-negotiation protocols. So these protocols will do those negotiation processes automatically. It will allow the switches or the ports, the interfaces of the switches to auto-negotiate some of these factors, okay? So that this process can be done with little effort from the administrator, okay? This process can be done with little effort from the administrator. Now, you let me know if you're able to see my slides, okay, if they are visible enough. Okay. Sometimes I realize that sometimes you might be talking, but the display on the side of the student is horrible, and Unfortunately, maybe the students might just keep quiet. So you let me know if what I'm presenting is clear to your side so that I can do adjustments as necessary. So I'm saying, so these two protocols, we have two major protocols that will facilitate this particular process. Okay. So there's what we call port aggregation protocol. Port aggregation protocol. And then there's what we call link aggregation control protocol, LACP and PAGP. G there is together with A for the word aggregation, okay? So don't confuse or don't find it difficult to know what is the meaning of G. There is an abbreviation that is take together with A for the word aggregation, okay? Now these two protocols, you'll choose which one to use. We'll configure Ether channels dynamically. Okay, configure dynamically. So in this configuration of dynamically, what we are avoiding is trying to enforce the implementation matrix or the implementation requirements manually. So that's why they are called auto negotiation. So they'll facilitate the interfaces of a switch to auto negotiate those properties until they are in a position where they share the required implementation matrix factors, and then they can now be able to initiate the Ether channel process. Okay, so that is the purpose of these two particular protocols. That is the purpose of these two particular protocols. It's called Link Aggregation Control Protocol, LACP, and it's called Port Aggregation Protocol, PAGP. Now, you don't need to use all of them at once. Okay, these are protocols that functions independently. Okay, if you choose to use LACP, then go with LACP. If you choose to use PAGP, then you go with PAGP. Don't use all of them at the same time. So major operation protocols for PAGP, it has three major properties. Okay, it has three major properties that will influence or will impact on its operation. Okay, so there is PAGP desirable, there's PAGP auto, there's PAGP on states. Okay, so you can the interfaces will be either of those be in either of those modes at any particular time. Okay, so if interfaces are configured in an on mode, they not necessarily need PHP to operate. Okay. If the interface is on PHP desirable, then it has the ability to actively negotiate or exchange what we call PHP packets. Okay, desirable. If the interface is on auto, it receives and responds, but do not initiate PHP negotiation. Do not initiate PHP negotiations. So an interface can be in any of those three modes. Now, those modes are basically the technical or the logical operation of a PHP protocol. But if you're doing the configuration processes, you don't need to worry yourselves with the process of how those three particular modes would be accomplished. Okay, you just need to know them in the theoretical view that is how the PHP interfaces interact. That is how the interfaces will be behaving in one way or another. Okay, so that's an example. If you configure PHP between switch 1 and switch 2, how the modes are going to behave. Okay, so at what point do we establish a channel, or at what point do we manage to combine those two particular interfaces that we have on switch 1 and then on switch 2, so that they operate as a single interface. Okay, so that table describes the particular outcome as under which the channel can be formed or the channel can be established. Now, so just in a similar manner to what we've just looked at above there, the operation is almost the same. It's only the wording that we are changing. What you also need to take note is that LACP is a universal protocol. It's not associated with any service provider. It's not proprietary. Unlike PHP, which is a Cisco owned protocol, LACP is 802.3 AD Institute of Electrical and Electronic Engineering specification standard. So you can use it in all type of switches around. In fact, that is the universal protocol that will support link aggregation across the board. You go to Huawei, you'll use it. You come to Cisco, you'll use it, and all other processes. So it has also three modes, and just similar to what, because proprietary protocols will always derive the operations from the universal or from the standards that are universally accepted. So the operations of PHP is directly derived from a LACP protocol. Okay, so those are just similar states as the one we had provided above there, on, active, and passive states. So a similar operation or a similar summary is provided there. So at what point do we introduce those particular channels? Okay, so what you need to be concerned about is when do we establish a channel? Okay, when do we establish a channel? Those are the areas that are of interest. Okay, so which makes will actually support this particular channel. Now, so the lab I've provided for you on the ZDS platform, the lab that I've provided on ZDS platform will provide a deep explanation. And I would love us to always look at those labs. It provides you with the tangible explanation, okay, on the theoretical concepts that we talk about here. Okay. The chapters are so many, and therefore we'll not be able to look at the lab, look at the theory, look at the lab, look at the theory. A concept that I think we can do with the lab directly, I'll always explain using the lab manual without the theory. But a concept that has a lot of theoretical theoretical perspectives, I'll always do the theory. Then you look at the lab, please. Okay, do the lab. See the challenges that are there. My WhatsApp is open. Cisco NetAcad has a way you can send message to the instructor. Send those messages to me. I'll be able to help where there's a problem. But what you can be sure of, we'll not be able to do lab theory. We'll be doing one and then you do the other. So it's upon you really to catch up with those labs. Okay, so the configuration process will just follow what we've talked about. One, I've said, ensure the communication properties are the same. This is basically what is being talked about here. One, you have to ensure that they are either talking the same speed, they're talking about the same communication mode, duplex, half duplex. There's a VLAN match. Okay, and it supports all the ranges of VLANs that is allowed in Cisco switches. Okay, so you need to ensure those are the same. And I did say that when we use the protocols, then it becomes a little bit easier for you to do the configuration process. So there's an example there. There's an example there. So look at those two switches that are provided there and the interfaces that we want to talk about. So switch 1 support speed is 1 GPS, similar to switch 2. In terms of duplex, they are all full. All the interfaces have been configured or assigned to VLAN 10 so that they're in the common VLAN. Okay, so what we want to do is to put up these two together, bundle them together. Okay, so you can see how much we're going to, how much speed we are going to aggregate together if each interface is doing 1 GPS. Okay, so you look at how much we're going to put together in terms of speed that we're going to do together. So while you're doing your labs, what you need to also realize that here we create that channel. So a channel must have a name. Okay, a channel must have a name. Okay, so those are the properties or the important aspects that you need to consider in performing your configuration for the switch, to put up your switch in that particular order. Okay, so I hope you'll be able to do that in when you'll be looking at your lab. When you go through your lab one by one, you'll be able to find a very elaborate way of configuring the Ethernet channels on LACP, and the properties that you need to put into action. Okay, so the lab will elaborate that very clearly. Good. So, any concern about configuration on aggregations? Okay, then we can move to something different if there's no concern. So remember, I also I'll challenge you to go and check. Remember that if you're doing the G interfaces, that is the gigabit interfaces, then you can only do up to 4. Okay? You can only do up to 4 interfaces in a single bundle. Okay, so check for if you're doing FA, that is the fast Ethernet, how many can you bundle together to into a single channel? Okay, into a single channel. Okay. Yeah. So if there's no concern, then let's move to something different. Okay. So I want us to look at something different on DHCP. Okay, this is also a very short module. We can run through it very fast. I'm sure all of us up to this particular level know that there's private IPs and there's public IPs. Okay. So if you're working with a network that is local, then your private IPs that should be assigned to your user. If you're configuring a PC or you're configuring any other network node, then there's a possibility that you can allow the network node to pick IP automatically from a DHCP server. Okay, so that automatic assign and reassigning and renewal is the purpose of what DHCP protocol is supposed to be working for. Okay. So let's look at what this module is about. Now, so you see that the module is reading DHCP version 4. Reason being, there's DHCP that is serving IP version 4 addresses, and there'll be DHCP that is serving IP version 6 addresses. Because the two addresses are completely different from one another. Therefore, it means the configuration is going to be a little bit different, especially when you are configuring the range or the domain where the IPs are going to be drawn from, what we'll call the pool of the IP addresses. Okay, so you can't mix those two addresses. You can't have a single pool with IPv4 and IPv6 together. So that's why we distinguish the two addresses. So let's look at the concept. And if you've never known the definition of a DHCP, then today you pick it from here. Dynamic Host Configuration Protocol. So we normally call it DHCP server. Okay, that's supposed to give us those IP addresses. So this is particularly important in a big network, okay, and a network that involves wireless access. In a wireless access, doing static IP assignments is almost impossible. The reason being, people come, pass by, connect, go away, come by, pass by, connect, go away. So that means you won't be able to fulfill that requirement. If you as an administrator, you decide that you're going to do this process manually, okay? So DHCP server will always assign IPs based on a particular time frame. So it can be released within an hour, 2 hours, 24 hours, and so on and so forth. Okay, so that is called the lease period, the period that a given device or a given node in the network is given that IP address. Okay, so you can clients or DHCP clients can always renew that release, that lease period, so that it can be extended before it expires. Okay. So that is operation of a DHCP server. We've just mentioned it, how it works. Okay. So when a client connects to a network, it will request for an IP. Okay. It will request for an IP. That particular process is there. It will request for an IP. The request is done through what we call a DHCP discover message. This message is broadcasted because at that particular point, clients do not know exactly the address of the DHCP server that is providing these IPs. So it will do a broadcast. Any DHCP server that has IP addresses in the pool, that is, if the network has several DHCP servers, will reply. Okay, will reply with the offer. Okay, so the offer is unicast. Reason being, I hope you can be able to see my diagram. The offer will be unicast. Reason being, the request or the discover message had the address of the node that is requesting for the IP. So this one is known. So the DHCP server doesn't need to broadcast again. Okay. And then the client will send a request so that I've known this one will also be will send a request, what we call the DHCP request, and finally an acknowledgement will be sent. So those are the four processes for obtaining an IP address from a DHCP server: discover, offer, request, acknowledgement. Okay. So when the IP is sent, of course, it will come with the lease period and all those kind of particular processes. So that's as simple as that. That's what happens when you get into a network and you want to connect to that particular network. Now, so if the period for which the IP was assigned is coming to an end, is coming to expire, then DHCP clients are allowed to renew the lease period. So because the client knows the server that had issued the IP, it will send a request message. Okay, for the renewal of that particular IP address. Of course, it's in form of an offer, but requesting for a release, because the server will realize this IP address is being requested is still owned by the same device or the same node that is requesting for it. Okay, so a DHCP server should acknowledge that request, what we call a DHCP pack message. Okay, so of course, if the server maybe is no longer active, or the server went down and so on and so forth, then this message will not be received, the acknowledgement. So there's that minimum time, or that configurable time that the client will wait, upon which, if that message is not received, then the client will do what we call a broadcast now to any DHCP server that is in the network. Kindly renew that IP address. And we are saying the offer and the acknowledgement of DHCP pack can either be unicast or broadcast, depending on or based on the request for comment document by IETF, the Internet Engineering Task Force. Okay. Now, we all know the IP addresses that are reserved for broadcast messages, IP addresses that are reserved for multicast. Of course, unicast, we don't need an address. When we're doing unicast, I'm sending it back to your IP directly. I know you, so I don't need any other form of assistance. Okay, but you need to know the type of addressing that are reserved for multicast and broadcast addresses. Okay, so that's basically what a DHCP is supposed to be doing: give out IP, maintain the lease period, renew the lease period, and so on and so forth. So the IPs that are being given, I've said they are come from a pool. We decide the pool that we're going to draw these IP addresses, and they include even the gateway address and the DNS address. Okay, so we're going to see a simple lab here. Then, of course, you can check on your lab that I've attached on the ZDS platform to see exactly a little bit more elaborate lab, or a little bit complicated lab, just to advance this concept of a DHCP server. Okay, so in that diagram there, you need to configure the Cisco router. Okay, maybe also to mention is that if this network is small, If the network is small, then a router that is maybe serving as your gateway can also serve as your DHCP server. You don't maybe need a dedicated server for that particular process. Okay, so in this scenario, the expectation is that this router here is going to be a DHCP server and should be able to award IPs to these clients, to be able to award IPs to those particular clients automatically. So our steps in this configuration, specify the pool. Okay, specify the pool. Your pool should come from the IP addresses that maybe you've subnetted, or from your primary IP address. And within your network, you need to exclude from your pool IP addresses that are manually configured, meaning IP addresses that are given to services that should never be out of the network. For instance, you have a server that is hosting maybe emails, you have a printer that is serving so many people. Those IPs must be out of that particular pool so that they don't be, if they are given out to, or the server keeps on changing IPs, then definitely your users will never be able to get that server in that network. Okay. So manually configured IPs must be reserved, must be out of that pool. So the command is this. We're going to see a simple configuration just to see how the pooling is done. So you give the name. A pool must have a name, just the way we were saying up there that a channel must have a name. Okay. So so some of the addresses that you can be able to exclude from your network, some of the addresses that you can be able to exclude from your network are provided here. Okay. So that is the syntax. That's the syntax of assigning those addresses. So these ones can be counted as the pools that would require manual configuration, so you don't need to include them in your pool. This is the command you use to define your pool. We're going to see a simple example here on how that can be done. Okay. Yeah, so from the example there, our command is very short, as simple as this. Okay. So one, you begin by excluding IP addresses. So for instance, here we've excluded IP addresses from 1 to 9 because it's the same network. It is network 10. These are class C IP. So the command is IP DHCP excluded dash address. So these are the addresses that we've excluded. So if we are going to assign maybe the gateway address, the DNS, and so on and so forth, we can pick those addresses from this excluded pool. So these are range, okay? These are range. We also exclude another address that is far much beyond this range. That is why it was not included in the first command, .10.254. Maybe it's for something else that is going to be assigned within the network. Then you define the pool name. So you say IP DHCP pool, then this is the pool name. LAN dash pool dash 1. Then we do our network. Okay. So if you see this type of network and you see this type of subnet, so you must supply your subnet mask. So if you see a 0 here and a 0 here, that means this network here, we can serve from 0 to 254. Okay, all these IP. So this network, of course, you'll never find a network of this nature where there was almost 254 devices in the same network. Probably it's going to be segmented into VLANs. Okay, but still you can have that a network with that range. Okay, so these are available IPs that we have now. 254 was taken. 1 to 9 was taken, so you subtract those ones from this range, and then you'll be able to get your available IP. So default router is given .1, which was excluded up here. .5 has been given to a DNS server. Okay, now you realize that DNS server is on a different network because it's .11, so we don't even need to exclude it because it's not part of the pool that we are defining here. Then, of course, the domain name is that provided there. Okay, so this command here is able to define a DHCP process. So what we also need to do is just to enable DHCP on those interfaces that are connecting to the clients. Okay, but what is important is how you define your pool of IP. So if somebody connect to this network, will be awarded an IP. Somebody connects to this network, will be awarded an IP. What we've not configured also is maybe the release period and so on and so forth. We've just created a pool with primary or manually configured IPs being excluded from the configuration. So those commands can be used to check just how the DHCP is working. Running config will basically show you the commands we've used in configuration. Remember, that is the configuration that we've just typed. DHCP binding will show you IP addresses that have been released or that are out there with their different nodes. And of course, the specific MAC addresses of those nodes. Okay. And of course, the DHCP server statistic will just show the communication, those discover request, release, acknowledgement, and so on, those messages that are coming in and out of the network. Yeah, so those are the output from those particular commands. If you do it practically on the lab, you'll be able to verify those configuration and see actual information. Okay, so like for instance here, what we have is this has been awarded an IP address, so that is the binding that we have. So meaning that one IP is out. Okay, and the messages and statistics are there. You can just have a look at them. You can check on the PC or the network and see who is giving them the IP and if it is automatic and if the IP is there and it's present. Okay, just do the IP config all just to check IP status. So the expiry of this information here will be calculated by default if you don't assign your own leasing periods. But the back to somewhere there. IP addresses, not all of them start with 192. 192 is the classes of IP that is in class C. Okay, and this is the widely used class because remember in an IP address there is the the host bit, and there's the network bit. Okay, the host bit and the network bit. So class C is used because it has the least number of bits representing the host. Therefore, it can serve smaller networks. You know, you don't want a network where the number of hosts in that network is 2,000. This will not work for you. Like class B. Class B has 16 bits for the host. What does that mean? It is 2 raised to power 16. How many hosts are those ones? Those are so many hosts. Okay. Maybe if there's a problem with IP, then I can either attach for you a slide there, or I can revisit that in the next class. Maybe for the first few minutes, we can relook at IP and subnetting. Then we move to something different. I'll make it a very short process, but I'll attach slides on IP on your ZDS platform. You can have a look at them. So 192 is the range for class C networks, network IP. Okay. There's class A that begins from 10. There's class B that begins from 172 dot. Okay. So it's not that all IPs begins with 92. This is just the default IP for smaller networks, like the one that you are prepared to manage, the local area networks. That's why we use it quite often. So this is how to deactivate DHCP server. So you go to the router that was configured to work as DHCP server, just say no DHCP service. That router will go silent and will no longer issue IP addresses. Will no longer issue IP addresses. Can you hear me? I hope you can hear me now. Connection briefly. So I'm saying the relay is supposed to help us in a scenario where we have 3 different networks, or 4 or 5. Okay, so I was giving an example that if you have network A, network B, and network C, and your DHCP server is in network A, your clients or your computers or network nodes in B and C will not be able to receive IP from the DHCP server located in network A. So what do we do in such a scenario? Okay, in such a scenario, we configure the routers connecting these networks. Okay, connecting these networks so that they can relay the broadcast messages for DHCP to the other routers. So C can relay to B and B can relay to A, and then A can respond. Okay, so that's what we call a DHCP relay. We call it helper. Okay, the configuration of the command is helper. I'm just going to show you how to do that. Okay, so that it enhances this communication process. Okay, so the scenario given here, our DHCP server is here. Okay, our DHCP server is here. These are 2 different networks. Remember, when there's a router, one interface of a router is a network, one interface of a router is a network. So if this is network A, okay, and this is network B, then PC on this other end will not be able to get services from this DHCP server if the router here is not configured with the relay, so that it can relay broadcast messages to this other end. Okay, so that's what I'm talking about. So we configure helper so that router knows that if I receive this type of message, it is a broadcast message for DHCP, and therefore I need to forward it to the next address. Okay, basically from the word relay that message to the next person, or share that message with the next person. That's what we are really doing there. So the command is you put the IP of the next IP address of the next interface that you want that message to be relayed to. Okay, so we call it IP helper address. Okay, so if you check the interface that has been configured with that command, IP helper address, okay, then what happens is that what happens is that if you check the that interface statistics, okay, if you check the interface statistics, then you realize that it's showing the helper address here. Okay, it's showing the helper's address, meaning if the router receives that, broadcast, okay, receives that broadcast, then it should forward it to the helper address so that it can be forwarded to the next device. Okay. Okay, so the configuration command is here. Just access the interface that of the router that you want to operate like a helper, or to relay that message. Then you put the right command. Remember, switches cannot operate like DHCPs, so that's out. Okay, it's either a router or a server. Okay. Okay, so other services that also depend on the helper address are these ones. These ones, some of them we'll be looking at later. Like, for instance, if I talk about TACAS is about logging in. If you're logging into maybe a server or a network, this is a server that is supposed to be doing what we call use authentication. It's supposed to authenticate you before you can be allowed into the network. Those are the ports. DNS, we know domain name server, what it's supposed to do. FTP about uploading files, and of course NetBIOS services. So these are other services that can also rely on DHCP or relay services. So like for instance, if I log in, the router needs to relay that information to the TACA server to be able to authenticate me and allow me into the network, okay? Okay, so any question on DHCP? Any question on DHCP? I would request that you you do your lab and kindly communicate back if you have a challenge. Okay, communicate back if you have a challenge. That's when I'll be able to know whether you understand what is being taught or not. Okay. So do those practical assignments and communicate back. Do the configuration and check if your devices that are attached to that network receiving IPs from your server and the IP addresses are from the pool that you had configured within your network. Are they from that particular pool? Okay. Yes, so that's about DHCP. That's about link aggregation. If there's no question, then we can I can allow you to go and do the lab and communicate back to me your outcome. Okay.